to Silicon Valley, and Mike's been in Silicon Valley as long as I have. He's worked at a lot of these big companies, LinkedIn, Intel Labs, eBay over the years. And he's got a fantastic educational background as a linguist and a cognitive scientist. So he's very knowledgeable about knowledge graphs. So we're going to definitely be talking about the knowledge graph biz, as it were, and how it's evolving. But Mike, I just wanted to start with how you got into this field. What was your interest when you started?
Oh, that's really interesting. I drank the Kool-Aid a long time ago when I was an undergrad, and I had a crazy mentor of a professor who was starting to build the foundations for what today we call knowledge graphs. So I got into it very early as a linguist, applying the skills that we learned for analyzing language and in particular semantics. But he was cross-appointed in computer science and library science as well. So he was looking at promoting using knowledge graphs as the library of the future.
And I've worked with librarians at PwC, for example, and we know a number of librarians in semantic technologies area, and I have the impression that they're underutilized, that their capabilities are really directly relevant to what people are trying to do with knowledge graphs. Is that your impression too?
Yeah, they seem to be the only people who actually have training in doing things like classification. And that right there is a big start. We can't go out, and when I built my team at LinkedIn, I had to explain what HR people what taxonomists and ontologists were, what they look like. And we couldn't just reach out to the nearest university program and say, okay, give me all your graduates in the knowledge graph development program. And it's nothing like that. So in many cases, I've seen people go to the library science department to get someone who's at least, has some training.
Yeah, for sure. And in general, it seems like there's a lot of different roles and skills. When I was at PwC, we did a project where we were trying to link 6,600 skills of the firm to various opportunities, so that and do that in an information system, so you wouldn't have to manually match skills to engagements. And so you have all these different roles in an organization, and it just seems like in general, this whole AI challenge could benefit from better use of people in various parts of the organization.
Yeah, that kind of interdisciplinary thinking isn't really very common. People seem to prefer cubby holes. Oh, you do this, end of story. So that's a challenge for that. Keep talking about it. Okay, Alan? More people have to hear that point of view.
For sure. And so you've worked with data science teams over the years, and you've worked on programs that have particular goals. Can you talk a bit about one of those programs and what the objective was and who was involved?
Sure. One of my favorites is a little project we ran at LinkedIn, a side project actually. I bumped into someone, a director on the bus to the train, and who said it would be really good if we could get LinkedIn to surface sustainable jobs, green skills, green jobs, these kinds of things. I said, okay, sure. You want us to look at it? All I need is an intern, a contractor. And we got into this, and it turned out to be something that was really useful. And another green jobs report just came out this week, and they still use, I think, the knowledge graph, the little knowledge graph that we built. And that was hosted in the analytics, the economic graph team. But we went in and we started defining, well, what does it mean to be a green skill? And what are the parts of green skill? And what are the greener kinds of skills that people might have? And based on that, oh, there's this job title here that doesn't say anything about sustainability, but it looks like a pretty green job title, like a hydrographer, for example. Who knew? Okay. So based on that, we pulled together, a nice little knowledge graph about what sustainability means and what kind of skills are involved. And that's what powers all the green skills and green jobs reports from LinkedIn.
That's cool. And so a success story. And what do you attribute the success of that effort to? What made it successful? I mean, you were allowed to basically do what you thought you should do, for one thing. I mean,
Well, they
did you
were
have the
stuck.
autonomy?
Yes.
What's that?
Yeah. So
Yeah.
I got the autonomy comes from other people not knowing how the hell to even start doing this. So they did a couple of first attempts using job titles that had the word sustainability in it. Okay. And they were really not very pleased with the results. And it turns out that, well, guess what? There are a lot more sustainability jobs that don't have the word sustainability. So like you said, a big chunk of the success was, we don't know how to do this, fix it for us, okay?
Yeah.
And then the surprise was that based on that, they came up with, really solid statistics that drew a lot of attention. Okay. And then even the CEO said, hey, wow, this is interesting.
Yeah.
Okay. And this was a side gig for us as a little tiny group within my group.
Yeah.
But it was relevant and it was needed. There was a pain point to solve, and it worked out well.
So in one of your blogs, you were talking about benchmarking and metrics, and you mentioned statistics in this example. Can you share what kinds of statistics in particular were relevant and helpful, and
Well, for the kinds of things that they were doing, it was counts. They wanted simply reliable counts of things that we could call.
Mm-hmm.
We could explain why we're calling green jobs.
Yeah.
Okay. And once we could get the counts reliable and say, well, this is why we're counting this as green, then all the other derivatives, like how this changes over time, how this changes regionally, how these jobs show up in different titles, all this started to make more sense.
And so it just seems like the power of the classification ability
Exactly.
is just really key there.
It was in that
It's
case.
like, yeah. And I've been looking at benchmarking for knowledge graphs, knowledge graph platforms, and there are assertions of particular levels of accuracy, for example, and it's hard to know what that means, what that
Totally.
metric means. Classification is one aspect of this. Are there other aspects that come to mind if you were to benchmark a knowledge graph platform?
Yeah, well, sure. So classification, at least the way I look at it, revolves around a single relationship, like parent
Mm-hmm.
of or subcategory of or something like that. And for knowledge graphs, we have a wide variety of other relationships that we want to track and benchmark and keep and pay attention to. So the way I usually think about it is, usually relation by relation assessment. How well are we doing with this one? Oh, subcategory of or parent of working fine. What about used for? Oh, that's not working so well. So that's how we ended up approaching things. It's kind of, if you think of it as a spreadsheet, then we would go column by column.
Yeah. Yeah.
And each column is a different relation.
Right. And it sounds like there are familiar relations that you work perhaps repeatedly with.
Yes.
And there's this whole notion of a shared ecosystem where you've got shared ontologies, you've got shared relationships and systems. Is that something that you favor in your work? Or you
This is definitely a key area of interest, something I'm fascinated by. We have a lot, actually have very many taxonomies and ontologies and knowledge graphs wandering around. But at the moment, they're not interoperable.
Yeah.
So we can't, it's very difficult to leverage someone else's. This is something we spent a lot of time trying to do at LinkedIn, and we're by and large not very successful. So that was a problem I spent quite a bunch of time thinking about. And I think that's got to be one of our next goals, is figuring out how to do that reliably.
It's a big struggle. I've talked with the people who are working on the standard business report model, making spreadsheets dynamic and shareable and ideally interoperable, and the conversations that go on behind the scenes to try to make that possible. There's a lot, and these are people who've been in standard XML approaches for business reporting. You know, they're accountants who do public reporting for companies. They know the XML version of things, but there's not a lot of semantics involved in that. So now they're getting into the semantic discussions, and it's not easy.
It's definitely not. So part of the problem, I think, in my experience, because I worked on standards projects as well, is most people think of standards in terms of what I call hard standardization. So we'll do things this way, and whatever you had before, you have to set that aside and then translate it all into this new way. You can contrast that with what I'm calling soft standardization. So do we have rules or algorithms that will allow us to translate between your version and this other version we're going to use for interoperability? Right? So you may remember a million years ago, the people at Stanford came up with something called KIF, Knowledge Interchange Format. And the whole idea was exactly that. Let's translate whatever you have, or at least map whatever you have into this interchange format so that we can get them more interoperable. I think that's probably definitely more robust, but a more plausible way of going about trying to do this.
When you described that, I immediately thought of Esperanto. I don't know if that relates at all.
It kind of does. Esperanto had its problems from the linguist point of view, right? Because what was behind this was this hegemony of European languages.
Yeah.
So, but
I see. Yeah.
So there were some issues like that with Esperanto, but that's not involved in things like, KIF and other ways of soft standardization, I call it. So you keep doing things the way you're doing them, but we'll develop an algorithm that will map them to this standard that everybody else is going to use for interchange or interoperability.
Yeah.
I think that's an important concept. Something I'm really interested in.
It is. So there are those who work on this kind of thing specifically, and then there are data science teams and data engineers, and there's the whole remit that companies have to think about when it comes to AI, and executives often are very anxious to adopt AI.
Something like that, yeah.
Yeah, so you'll see a lot of people hired who have particular skills in neural networks, statistical machine learning, etc. What's your experience been working with those teams, and how they react to knowledge representation in general?
Mixed. Okay.
Right.
But generally it's positive, because at a certain point, we get to the point where I spent lots of years learning how to speak geek. So I'm kind of bilingual here.
Yeah.
All right. And I've had to study on my own enough to keep up with them and be able to communicate with them and say, look, this is what your model is doing. We can add to that. So one of the key things, for example, at LinkedIn, the tech stack was based on machine learning models. Okay, and when you look at the equations and you see, oh, wait a minute, it's assuming that this feature is independent of this feature and this other feature. There are no relations baked into the equations for standard machine learning models. So what do? We bake the relations into the data so that they have those that they can draw on. use the same, they use the same tech stack, the same things they were doing, and this is how we made it work at LinkedIn. And this is how we could explain to them, look, cool, your models aren't taking into consideration these kinds of things, so we'll put them into the data, and you'll have much more to work with.
Mm-hmm.
And
Makes a lot of sense.
I think this is one of the things that motivated the move to deep learning, which goes the opposite extreme and says, okay, everything is related to everything, and let's see what shakes out.
Oh, that's true. And you're confronted with so many irrelevant relationships that you have to sift through just to get to the meaning.
Exactly. That sort of thing.
Yeah.
So it makes sense that things would be this way. Engineers don't have any training at all about the qualitative side of things. They have really wonderful training in math, but when it comes to anything like, linguistics, for example, they've never heard of it. So
Yeah, and the way you phrased it triggers a thought, because you've got the qualitative versus the quantitative, and as a researcher, I always started with the qualitative.
mhm.
Establish what you can establish with the qualitative, and
Yep,
then whatever quantization you can do.
is a step
Um,
forward.
yeah,
Right.
but without that qualitative base, I would be very confused.
Yeah. On the other
Um,
hand, there's huge power in the training that the computer scientists get
yeah,
because it's maximally domain independent. So you can use it anywhere,
right.
right? So they're doing math that you can use anywhere. They're doing techniques that you can use anywhere, data structures you can use anywhere.
And in terms of knowledge representation and linguistics, I've come across methods such as role and reference grammar. It's supposed to be multilingual. Are those
Really? Yeah.
successful in what they try to do, or
Oh, I haven't seen Valent stuff in a long time.
yeah?
They're trying to reach one thing they have in common is trying to reach a higher level of abstraction. Okay. And in that sense,
Yeah.
they can be applied to different languages. Um, the role and reference stuff starts doing roles are very similar to the relations that we see in knowledge graphs. So
Hmm.
yeah, it's a kind of a half step that way.
Yeah.
I mean, the things we use in knowledge graphs come very much from Charles Filmer's work on case grammar in the
Okay.
60s. That was the
Uh-huh.
foundation in the 60s for the first generation knowledge representation in the 70s. Okay.
Hmm.
Cool. It depends on how you're focusing it. So the way I look at it now these days, I'm much more a cognitive scientist. So I look at these roles as concepts rather than as aggregations of linguistic relations. But there is the
Right.
whole continuum of looking at these things.
Right. Hmm. So just getting back to the relations, and getting started with the relations, and I think you've built a good uh, common understanding here when we've been talking about how to get started simply. But let's
Mhm,
say that you're at a company that has gotten started and they want to put together a long-term plan. You've got the champion, you've got the leadership on board with a hybrid approach to AI.
mhm.
What occurs to you? If you had to put together a roadmap today, what would it consist of?
So not coincidentally, we have two kinds of clients. On the one hand, we have the clients who are in that kind of situation. They know they can understand that this is going to be important, but they don't know how to start. And the other kind of client is someone who doesn't know how to do it, but does it anyway. And then they get stuck. Okay. So it's the same
Hmm.
sort of thing. And then we go back, and the work I do is very much a mix of design and training and helping the people understand why things are the way they are in the knowledge graph. You don't want to take this kind of information and put it one place, the other kind in another place. Um, and then the roadmap is cool. Once we get some of these foundational issues settled, we're all on agreement about why we're doing this and how we can move forward, then the roadmap many times is just from one relation to the next. So we need these. We absolutely definitely need these relations, like the ones you mentioned before that are most often used. And then we see, depending on the use case, we're going to need something new. And this is the pattern I see across clients really systematically. We have a core set of relations that kind of get us started. And then we see, okay, well, what does your use case require?
Yeah.
Mm-hmm.
Yeah. And here in the Valley, one of the things I've encountered that seems relevant here is that you'll be working with a certain group of people, and you'll be able to establish some things like you talked about, and get this common understanding going. But then some of the people leave from
Leave, and
the
someone else comes in, and it's like,
yeah.
oh, you're the
And
cleanup crew. Oh, okay. Your job is to clean up the data. This is what we used to get all the time at LinkedIn. Okay, you're the cleanup guy. Well, we're not janitors. That's the first thing we have to say. And the second thing I kept saying was, we don't clean up the data, we enrich it. Because if we clean up the data, then we lose the robustness of the algorithms, and that's deadly.
Yeah.
So we keep the junk there, but we annotate it so that you can treat it as if it was good data. This is an ongoing conversation.
For sure.
That's why you're laughing.
Well, it's hard to think about the fact that you're working with a company and you get to a certain level of maturity, and you're excited, and people are things are firing on all cylinders, and then all of a sudden, the champion leaves or something, and you're starting from scratch in some ways, and the artifacts, the things that you're working with that have the power in them, have the knowledge power in them, if they're not utilized, they're not having the benefits that they're designed for.
Exactly.
Yeah.
That's right. Yeah, that's an ongoing issue.
Yeah.
Somebody has to feel the pain, and we can bring the Band-Aids.
Right. Are you talking with more people who are feeling the pain? I mean, what are you seeing out there in the opportunity space?
What am I seeing? I don't feel as much as there are more opportunities, but I'm seeing better opportunities where people are not just curious, but they're convinced that this is something that they have to do. Okay, maybe it's just because these are the people who get to me, who reach out, but I'm seeing more of that. People understand better why they need to have some sort of knowledge graph.
Yeah.
So,
And
I'm seeing that.
are they making clear distinctions between somebody with your background, for example, and somebody else who's got some kind of knowledge graph that they might have cobbled together, and it's not systematic in the way it was developed? I mean, are you able to really make those distinctions clear for people who are considering different approaches?
Yeah, so this is one group of clients that I have is the ones who started it, and all of a sudden they say, this isn't quite working. We know it's supposed to work, but it's not quite working the way we expected.
Yeah.
Or we don't see how we're ever going to scale it up. Okay, and then they reach out and say, can you check it out? Check out our system, maybe do an audit or something and tell us what's going on here.
Yeah.
And it's like, oh yeah, sure, of course, there are things that you didn't think of yet. Or you made these assumptions like this would work well this way, but we know that it won't.
Yeah, for sure.
So, but these are people who have a vested interest in making knowledge graphs work, or ontologies, sometimes they call them.
Yeah.
Okay, that's cool. So I'm seeing more of that instead of people who are just kind of like, okay, well, what's this knowledge graph stuff?
Yeah. And are you still focused primarily on the tech sector? I mean, companies that would be local to our geography, for example, or are you working in other industries?
Yeah. So I have a client. It's a mix of tech and entertainment that's partially in our geography, and another client in Europe that's HR tech. So those are just two,
Yeah.
but it starts to get diverse. And now I'm working with a company that's doing video generation. So
Wow.
it's really cool.
So video gets into an entirely different realm in some ways. I mean, the methodologies are certainly the same at some level, but what are you encountering with the video?
The video so the video part itself is
Hmm.
not what I'm so much involved in, but it's
Hmm.
kind of the front end where you want to control the system to do what you want it to do.
Yeah.
So that boils down to what we usually do with knowledge graphs is we use them to be able to communicate with the system. Okay, and if we communicate in a truncated or incomplete way, we count on the knowledge graph to fill in the blanks.
Yeah.
So that whatever system it is, it could be search, it could be video generation, it could be ads, it can fill in the blanks.
That's
Well, we fill in the blanks so we can work better.
right. We've got the communications network that has all these multiple uses.
Yeah, that's
And
that's how I
yeah.
look at it. So
And so you think about software developers and paradigms shifting, so to speak, with agents. And I've said before that it seems like most of these AI startups are putting the cart before the horse with
mhm,
agents.
yeah,
That the horse really needs to be in front, and you have to have the power to pull things forward. Um, is that your impression as well? I mean, how do you have a discussion about agents with those who are really interested in agents?
with agents we have the same. We have actually twice as many issues. So
Yeah.
one issue is how do we communicate with the agent so the agent actually understands what we need it to do. And then even worse, how is the agent going to communicate with another agent that might have been developed elsewhere,
So you have
right?
the interoperability problem
Yeah,
sort
in
of
spades.
magnified. Oh
Yeah,
my gosh.
exponentially, actually. And if you're generating armies or swarms of agents, then guess what? This is Babel all over again,
Yeah.
right?
Oh my gosh.
So the robotics people know about this. They have some, communication protocols, but they're very low level.
Yeah.
Um, and now the question is, how can we make those communications protocols, semantically richer, basically, and more reliable?
Yeah. And your company is called hypergraph.ai. And
Yeah,
I was thinking in terms of robotics, and I came across what Hanson Robotics had funded years ago, which was a hypergraph system. Um, and just for the purposes of definitions and your interests, I always think about hypergraphs as relations on relations. You've got, uh,
that's one
uh,
kind.
yeah, but maybe you could have a more suitable definition and describe what you think about in terms of hypergraphs and relations.
Definitely. Oh, so technically, hypergraphs are defined as relations that have more than two arguments,
Right.
more than two nodes, one edge with more than
Hmm.
two nodes. So you have a
Hmm.
collection of nodes. Okay. I'm fascinated by them because this is what we're going to need as we move towards describing processes and actions. They're very, very difficult to describe with these little triple thingies.
Hmm.
Okay, we need hypergraphs. Okay,
Yeah.
so this is my interest is creating the foundations to make this possible and easy as we move ahead.
And are you
Okay,
seeing a path forward where this is feasible and ready for prime time?
yeah, definitely. So this is something was actually a big focus when the work on knowledge graphs started. under good old first generation AI.
Mm-hmm.
So they worked out a lot of details about how we would do that. A lot of my work for years was, okay, how can we transform free text, technical text, into knowledge graph format and move on from there? So that by definition said, okay, if you're talking about positron emission tomography, you need to talk about events and processes and things like that. So there are tools, there's a foundation of tools that I think we can still leverage to go back to that. For the longest time, people have been focusing only on objects, right? Objects in a taxonomy, objects in an ontology. But when you look at the relations they use, they're just a plain list.
Yeah.
And like you said a second ago, well, what about the relations between those relations? We need those. And what about more complex relations that have more? I mean, how are you going to talk about a sales event with a triple when you have someone buying from someone else a product for a price? We can't do that with triples in a way that makes a lot of sense at this point.
Yeah, and it seems like the whole dynamic of event-driven systems, you mentioned events, it seems like that sort of hypergraph approach lends itself to an event-oriented, event-capable
It's necessary for
description.
representing things like digital twins.
Yeah.
Right? It's not a key area that people are talking about a lot. They're kind of focusing on getting used to simple triples. But I think it's more than feasible to move on from there to tuples, you might call them. So that's it. If we move on to tuples, then what do they have to look like?
Yeah.
And that's something I've been working on.
So as a part of client work or just on your own?
On my own, getting ready so that I'm prepared to meet the needs of clients who have to do this.
Right.
So I can see this happening very soon. If you're generating video, you're going to want to describe actions and events. And triples won't do that in a way that's going to be scalable.
Wow.
And I'm thinking the same thing.
How does reasoning factor into all of this? Because
yes,
it's sort of like you've got the method down for keeping this simple. It sounds like to me. You've got an approach for people who are just getting started. Okay, here's the classification approach that you take, etc., which all makes total sense. And then you have the formalists, I would think about in the semantics community, who are very passionate about reasoning ability, inferencing, etc. But then that gets very complicated in some ways, doesn't it?
Yeah.
So, but you want that reasoning ability, and you want to be able to implement it when there's a real need for it.
Yeah. Yeah. So the people in the formal community focus a lot, in my understanding, on hierarchical relations, like the subcategory of the ones that are amenable to formal logic. And then they start having problems when we branch out into other kinds of relations. So I think we have to step back and think about reasoning more broadly, not as broadly as the LLM community thinks of it, which is just basically anything counts as reasoning. But we can, if we start from a knowledge graph, then we can identify and classify the different kinds of paths we can take within the knowledge graph. And that's kind of reasoning. And the kinds of information that you want to gather along the way as you traverse a path, that's a kind of reasoning. And then how we can make hops or go around gaps in the knowledge graph. That's a clear kind of inference. But I think that's much richer enterprise than what formal logic would have us do with deduction and induction.
So we're sort of going down a rabbit hole to your mind with the formal logic that we're sort of missing the bigger picture here?
Golden handcuffs, right?
Interesting.
That's my take. So there are
Yeah.
lots. So like with any tool and any system, you buy a tool, whatever tool that you want, but you're also getting for free, as it were, all the assumptions they made when they built it.
Yeah.
Okay. And then you have to deal with that because sometimes those assumptions don't match your use case. And it's what we have a lot with formal taxonomy work, for example. Oh, there's only one kind of relationship. You can only have one parent node. And there are a bunch of constraints like that, like the MECE, MECE assumptions that really tie our hands in many use cases. So I'm kind of skeptical of, I can see the uses for a lot of these formal systems, but it's really clear that we have to make them richer to meet our needs now.
Yeah, it goes to the notion of what constitutes a viable architecture,
Mm-hmm.
and so if you've got all these constraints that you have to deal with, given your methodology, and you've talked about this in other ways before.
Mm-hmm.
You've blogged about let's just dispense with Boolean logic, for example.
Oh, please.
Because it's overused, and it's so
Mm-hmm.
overused that we just trip over it all the time. Is that
Yes.
a fair statement?
It's, again, golden handcuffs. It's
Yeah.
comfortable, it's traditional, we know about it, we can do things with it, but there are a whole lot of things that we can't do with it.
So
Right? We
how do
can't
we
do
get to
things
that
like
broader
we can.
mentality that you're pointing to? I mean, because a lot of people people who've been to school and they've
Yep.
studied philosophy and they've had courses in logic. You see a lot of these people in knowledge representation today.
Mhm.
How do we free them from the golden handcuffs in a way?
That's really difficult.
Yeah.
I work hard at talking about it and trying to show things that we could do if we gave up on this assumption or that assumption. Um, like you said, a bunch of blog posts about that. And other than that, we have to try to work out systems to show, hey, look, now it's working, and this is why it's working, because we dispensed with this assumption here that other people have been making.
Yeah.
So that's how fuzzy logic became very well known. They just changed a simple assumption of, instead of binary truth values, we would have continuous truth values, and this is actually what underlies most of machine learning, fuzzy logic assumptions.
Right. So, to your mind, the machine learning approach um, has all the has a lot of flexibility. In other
Mm-hmm.
words,
Yes.
but sometimes you get into trouble because there perhaps is too much flexibility, and or
I
it
don't
just seems
usually
like.
see that. I usually see too
Hmm.
many constraints.
Yeah.
So this standard equation that a machine learning system will look for is one where all the factors are independent of each other. There are no interactions. Okay, that's fine. It works really well in many contexts. But it's also the reason why we need such huge amounts of data.
So it
It's
just
just that
seems.
the equation is too simple. That's all.
Yeah. It seems if you build the context first, then you're just dealing with the context, context at a time, perhaps. And that seems inherently more efficient. If you've got if you've described the subgraph or the piece of the mirror world sufficiently well, then it would seem that you don't necessarily have to
Yep.
do this brute force
Totally.
processing all the time.
Totally. Yeah. So
Yeah.
this is the principle that with structure we reduce entropy.
Hmm.
Okay. And if we have a lot of entropy or error variance, then we have to have more data to make up for it and find reliable conclusions or
Yeah.
patterns. Okay. That's a well-known trade-off. And
So,
I'm totally with you. The more structure we can feed these systems, and we saw this work extremely well at LinkedIn, the more we could give them, the more structure we could give them, the better the systems performed.
how does that relate to what's going on in data warehousing, for example, or transactional environments where they're working with tabular data and the relationships are foreign keys, for example, or
Right.
column headers or what have you?
Mhm.
Are you what's your perspective on that kind of structure and how it relates and how to use it?
I think it's the same situation. So the column headers are assumed to be, this is in the bowels of the database system, in the
Hmm.
original plans for them, they're assumed to be independent of each other, right?
Hmm.
Can you store in a database that column A and column C are subtypes of something else? Well, you can't. It just wasn't conceived that way. So the foreign key came up as a way of starting to do that, but we can't describe that. We don't have typed foreign keys, do we? We just have a bridge
Right.
and say, this row is related
Hmm.
to this.
Yeah.
Okay. So we have no type system for that. This is what we get with knowledge graphs is we're typing the foreign keys, as it were.
Yeah. And it seems like the labeled property graphs have that same dilemma as well, with not undescribed relationships.
So my take on label property graphs is that we can kind of separate out not the property graph as a language for describing facts from the algorithm that uses it. So I was puzzled for a long time about with this controversy over LPGs and RDF and all of this. And
Right.
when I started to look into it more carefully, I said, wait a minute, they're mixing up characteristics of the meta language we have for describing facts with what the algorithm does. And if we think of those separately, then we see that LPGs are actually pretty good as knowledge representation languages. They have some interesting advantages. They're more flexible for, you know, um, things like hypergraphs and relations between relations and these sorts of
Hmm.
things. Okay. And then we have to look at the algorithm and what is the algorithm doing with that stuff that we represented. And the algorithms associated with LPGs are right. They don't require that you have an ontology in there to define structures. They permit it, but they don't require it. So
Hmm.
I think there's more subtlety in the controversy than I read about.
Yeah, apparently so. At the same time, it just seems like you've got all these different methods that have some level of power,
Oh yeah.
and and people are investing all this time in using them. So you want
Mhm.
to be able to use them, but then you try to bring them together, and that seems like a big challenge.
That's
Oh,
perfect summary. This is why I'm so interested in interoperability,
yeah.
right? Because we have all of this effort and it's not going to be useful until we can gather our forces together, or at least our results together in a way that makes sense.
So I'm guessing you have a perspective on fair principles and what the pharmaceutical industry has been trying to do with fair and fair squared.
Yeah.
What is your perspective on that? Do you think the pharma industry is headed in a good direction? Is it helpful? Should other industries learn from it? What are your thoughts?
Yeah, I think fair is really an excellent way of thinking about things. Um, we want we want the things we produce to be useful to other people. That's summarize it rather quickly. I'm not sure about fair squared yet,
Hmm.
but fair to me, from everything I've seen, is it's a goal we can aspire to, and we should aspire to. So yeah, I think so. The one story I can tell you about the pharma industry was a hallway conversation I had with someone from one of the really big pharma companies, and I'm just making conversation. Okay, so how's your knowledge graph, and how are you using it? What do you use it most for, and this kind of stuff. And this director kind of looks at me and says, well, I tell you the truth, it's not very useful. And I was like, what? What's going on?
Mm-hmm.
So I poked and prodded and squeezed and mercilessly until I could wrap my head around what was going on. I like to tell this story. And it turns out what happened was they overinvested in these vague, uninformative, bi-directional relations, like associated with, or related to, or
Yeah.
similar to. So they have a million of those, and every time they type in a query, they get everything back.
Right.
So definitely not useful. That was definitely a good conversation.
Yeah, for
So
sure.
that's led me to start thinking about, okay, well, how could we profile a knowledge graph and see which parts of it are, we can call it, is it an obese knowledge graph that has all this extra stuff? And this is something that I'm seeing happen in the biomedical domain. They have lots of
Mm-hmm.
other things in the knowledge graph. And you want to say, okay, well, what are the parts of this protein and what are the reactions it participates in? But you have to wade through author of article, last edit date, all these other things. Synonyms, thousands of synonyms. Oh, this corresponds to this in this other group, in this other database. So I'm thinking we need a decent method to profile a knowledge graph and say, okay, so this is administrative information, this is synonym mapping information to other systems, and here's the core, the meat of the system. And how much is there?
Yeah. So different levels of abstraction that make it possible so that you're not overwhelmed with all sorts of things that don't seem to relate terribly well from your
Exactly.
perspective.
Right.
So,
Yeah. So I'm thinking of it as a way of tracking progress better.
Yeah.
Because somebody
Yeah.
can say, oh, we have a million triples in here. And you look and there's only, 1,000 of them that are really about proteins. The rest are about other things.
Yeah. Well, it
But I haven't.
seems like one of the things that came to mind here was that we're working on the corpus of information that enterprises or have available to them,
Mhm.
and trying to make it more reusable. But then there's the whole panoply of individual users, individual humans, and how they differ and what their needs are.
Mhm.
And so LinkedIn is probably a decent example of sort of articulating what the interest graph is, so called. And it
Yes.
seems
Yes.
like the interest graph is just as important as the content and the structured data knowledge graph.
It's just an additional knowledge graph.
Yeah.
So that's used to filter. They have something at LinkedIn called the interest graph. I helped build it.
Mm-hmm.
And there you go. It's a sub part of your knowledge graph that's topics.
Yeah.
And cool. So here's a piece of content. Which topics are represented in the content, and then then you can accumulate them for each user and say this 99% of the time this person likes this and this and this.
Right.
Yeah. But back to
But
the biomedical one for a second.
yeah,
I remember something
sure.
else. When I talk about obese or bloated knowledge graphs, this is probably one of the reasons why they're not being used as much as they could be. So I got this from someone I know who's a CEO of a company who serves big pharma with this kind of data. And when we got to talking, he said, well, there are really significant performance issues. The knowledge graphs are too slow.
Mm-hmm.
I said, okay, well, guess what? It's probably because there's all this stuff in the knowledge graph that's not related to how a researcher thinks about proteins or genes or whatever.
Right.
So that's my best guess at the moment, is that if we shard it, then we'll be able to improve performance enormously.
Yeah.
And I think that's, since they've invested so much, they have really substantial knowledge graphs there. But if they're storing everything together, the good, the bad, and the ugly, then it's going to be hard to use them effectively.
Mm-hmm. So the system that we envision and that's materializing now, that is a hybrid approach, a hybrid architecture. How would you envision it? I mean, what should be the proper hybrid architecture that brings together the capabilities of machine learning with knowledge representation and allows, for example, database retrieval after an LLM query? What components should be in mind, and what's the approach that you would take to building such an architecture or designing one?
So the key distinction here is between the LLMs and the rest.
Mm-hmm.
So from the way I think things are moving is to use the LLM for what it does absolutely by far the best, and that's as a interface with humans for natural language.
Yeah. Right.
Okay? And not use it as a reasoning engine. So that's the way I think we're going. The reasoning capabilities are very controversial, up in the air, and not very reliable. So once we have that distinction, we have a really good place to start. We have the LLMs do a really great job of accepting and producing natural language. Wonderful. They can also translate into any query language that we want. And then we need some sort of federated system where we have databases and knowledge graphs and ontologies and different things. We'll probably have to build a map of them as an addition, as a higher level layer for routing queries. But for the moment, it seems like something cobbled together like that is what's going to be best.
No. Could this just be a small language model rather than a large language model? And what about all the training that's been done on public web sources, scraping and such? Is that relevant to what enterprises need these for?
So it is. Small language models have the advantage that they're small and they're cheap, but they're not as robust. When large language models are available, that means they're just that many times more robust as interfaces. So that's how I look at them. If they're affordable enough, then prefer a large one for more robustness.
Yeah.
We can always, focus them on a particular domain, but I think that's a good place to start.
Yeah.
And then,
mm-hmm. I go to these infrastructure conferences, and the talk is about how much energy consumption there is in these AI data centers. And California, yep. For example, they're taxing the grid. The PG&E can't deliver enough capacity for the big data centers to do what they need to do. So there's been discussion about small nuclear reactors and putting in substations.
Islands.
Yeah, 3 Mile Island, et cetera.
Mm-hmm.
So there's obviously the situation with LLMs as they're currently constituted, and they're energy hogs essentially.
Yep,
Do you have a perspective on how knowledge graphs fit into the resolution of that problem?
So yes, there is a sizable literature that shows that knowledge graphs can help with training, and fine tuning, and every step of the way. I really like this review I saw once where every step we do in developing an LLM, if you add a knowledge graph to the mix, then it makes it work better. So, but I don't think they've been using knowledge graphs in the appropriate ways.
Yeah.
So what I've seen is they serialize them and they make believe it's the same as text.
Right.
So I don't think that's the way to do it.
No.
There's all this literature from graph neural networks and a whole range of things that we know that we can do better than that. But the interesting thing I saw was even with these simplistic uses of knowledge graphs, there was a significant impact for everything, for initial training, for fine tuning, for evaluation, for all sorts of things. So we know there are better ways of doing it. Imagine if the training materials were just knowledge graphs, for example, then the energy consumption would be 10,000 times smaller.
Well, yeah, and it's like we've got more feedback loops, feedback response loops than we've had before, but it's sort of like knowledge graphs have thousands of different use cases,
Yep.
and so they may be used in dozens of different ways today, but what you've pointed out is at every step in the process there could be a benefit to it.
Yep.
I'd be curious
That's
to
what the
see that.
literature. Yeah, that's what the literature is showing. I have a post on that. I'll dig it out for you.
Oh, okay. I appreciate it. Well, this has been a really interesting and useful conversation, Mike. So looking forward to 2026, we're coming up toward the end of 2025. Do you have thoughts about what you're anticipating, what things are going to be new and different that you're looking at?
So I think the trend, as you just said, towards small language models will probably increase because it's just too big for most normal groups to be able to work on a huge foundational model. So that's clearly going to increase. I think we have to do more work with semantics. So knowledge graphs, I expect, will continue to grow. So I'm excited about doing things like, how can we validate knowledge graphs automatically? How can we automate the building process? How can we check coherence of a knowledge graph? Or starting from a taxonomy, generate a knowledge graph from it. I mean, the way I look at it, with the tools we have now from LLMs, we can do thousands and thousands of things that we couldn't do before.
So just all sorts of available capability, but you have to be able to bridge the gap between LLM and knowledge graph and other technologies that are in play here.
Yeah.
So generalists would seem to be somebody who understands the bigger picture and both sides of that, or all sides of it, would be very valuable if you could just think strategically about this stuff.
Yes, but at the moment we need generalists who can get into the weeds and teach people how to actually do it. Right? So
that's the dilemma, right? Generalists are not known for getting into the weeds a lot.
I make a distinction you might find useful between computational tools, and we have lots of those, and they're really wonderful, and conceptual tools. So one of the things I like to do as a generalist is work on the conceptual tools. Okay, let's see if we can find a shared understanding of what a knowledge graph is and isn't. Okay, what is inference and what is it not? What makes a good knowledge graph and not? So I'm interested in those. I consider them tools as well that we manipulate to help guide us when we use the others.
Yeah, clearer distinctions along those lines would be really welcome. It'd just be good to have a distilled something that you could just share with an executive and finally shed some light on that. So stuff that we can hopefully will work on soon. So Mike, where can people find you? I know you're on LinkedIn. I know you're on Medium.
Definitely on LinkedIn. Not as often on Medium, on LinkedIn. And I have a newsletter called Knowledge Architecture that you can get at through my profile on LinkedIn. And that's probably the easiest way to find me.
Super. Well, it's been a pleasure to sort of unpack all these issues, and I appreciate the patience and the articulation.
Love it. Always a pleasure with you, Alan.
Yeah. Well,
we should do this more often.
Absolutely. We'll say goodbye for now and look forward to next time then.
You bet. Thanks very much. Great talking to you.